Hello and welcome back to another video on differentiation. Today we're going to be looking at curves, particularly explaining when curves are going to be increasing or decreasing by looking at the derivative of the curve. So we'll start off by defining when a curve is said to be strictly increasing or strictly decreasing. So we'll say that a curve is said to be strictly increasing, which means that it's always going to be increasing when the derivative dy by dx is greater than 0. We will also say that a curve is said to be strictly decreasing, and as you can guess, it's going to be when the derivative is less than 0. So let's visualize what this will look like. So as we said in our video about the equation to the tangent of a curve, we said that the derivative of the equation of the curve at a point x will give us the gradient of the tangent. If we can work out the gradient of the tangent, it will tell us if the tangent is going to be increasing or decreasing. And this simply means that if it's increasing, then the gradient will be positive, so it will be going from left to right upwards, as we can see here. Whereas if the gradient of a tangent is negative, we can see it will be going down from left to right in this example here. If the gradient is positive, we simply say that the derivative will be greater than 0. So therefore, the curve will be strictly increasing. Whereas if the gradient is negative, we will say that the curve is strictly decreasing. Now you will have noticed we've not looked at the example when dy by dx is equal to 0, but we will do in our video on stationary points. At the moment we're only looking at when the derivative is greater than 0 at a point or less than 0 at a given point. And this will give us information on whether the curve is increasing or decreasing. So using this definition, we'll do a little example here where we're told a curve has the equation y equals 4x squared plus 2 over the square root of x. And we are asked to determine whether the curve is increasing or decreasing at the value where x equals 10. So, as we know, it's strictly increasing if the derivative is greater than 0, or decreasing if it's less than 0, so we know we're going to have to work out the derivative. So let's work out the derivative dy by dx of this curve. Now before we do that, I think I'm going to make our curve a little more simple to differentiate, as we have, not only do we have a square root of x, but we've also got x as the denominator of this fraction. So I think I'll rewrite that as 4x squared plus 2x to the minus a half. And if you've forgotten how I've got to this, be sure to go check back on our video on finding the derivative. And now we can work out the derivative. dy by dx, which is going to give us 8x, and then plus 2 times minus a half, it's going to be minus 2 over 2, which is just 1, so we'll just put minus x, and then minus a half minus 1 is going to be minus 3 over 2. And again, I'll rewrite this with x as a positive power, getting 8x minus 1 over, and it's going to be square root of x cubed. So square root of x all cubed. And this is our derivative. Now we don't know yet if this is greater than or equal to 0, do we? So we are told that we're to determine whether the curve is increasing or decreasing at the point where x equals 10. So we know if we can substitute x equals 10 into this derivative, we'll now get a value and we'll know if that is greater than or less than 0. So let's do that. Let's say at x equals 10, the derivative dy by dx, just substitute in x to be 10 into this equation here. Well, we're going to get, let's see, we're going to get 8 times 10 minus 1 over square root of 10 cubed. Now in this case, we're going to rewrite this a bit. So we'll say this equals 80. And in this case here, we've got the square root of 10 cubed. Well, I think we'll just write that as 10 root 10. And the reason we did this is because root 10 cubed is the same as root 10 times root 10 times root 10, which is also equal to root 10 squared times root 10. And we know root 10 squared is just 10. So it's 10 times square root of 10. So that's how I've gone from this to this here. And then also here, we can just say that this is greater than 0. And this is because this value here is going to be less than 1. So if this is less than 1, we know that we're going to have 80 minus a value less than 1 is greater than 0. And if you want to visualize that this is less than 1, you can just put it into your calculator and you'll see that it will be less than 1. So we'll finish off by writing a little sentence at the bottom by saying that since, and we'll say since dy by dx is greater than 0, then the curve is increasing. And it's important to say what point it's increasing at. We'll say it's increasing, or we'll say when instead of at. Say it's increasing when x equals 10. It's important that we say it's increasing at this point here because it might be decreasing at a different value of x. So here's another example, and it's a little bit differently worded this time. We're not asked to find if it's increasing or decreasing. We are asked to show that the curve is never decreasing. So we know that if we do a bit of manipulation with the derivative, we'll know that it's never decreasing because of the derivative. So we'll get to that first by actually working out the derivative. So we'll find that dy by dx is going to be equal to a third times 3 is just 1. So we'll have x squared. We'll have plus 2x. The derivative of x is just 1, and the derivative of minus 4 is just 0. So this is our derivative. And we can simplify this a little bit. We can put this into 2 brackets. So we're going to have x, factors of 1, well, it's always positive, so it's going to be plus 1 and plus 1. So we can say that that's just equal to x plus 1 squared. And we know that any number squared is always going to give us a positive value, and even for negative values. So even if x were, say, negative 3, we would get minus 2. Minus 2 squared is just 4. So we know that for any value of x, the derivative will always be positive. So we can do a little notation if we want. We can say for any x in the real numbers, the derivative dy by dx will always be greater than 0. So the curve is never decreasing. Now there's multiple ways you could have stated that as well. You could have also said since the derivative is never less than 0, it's never decreasing. Or in my case, I've just said that for any value of x, it's going to be greater than 0, so it's never decreasing.